when programming, we will have situations when we want our program to run based on certain situations, or we want some piece of code to execute only when some criteria is met. So perhaps you have a program that grades people based on their score. So you have someone who scored 99 and you want to say, okay, you scored 99, you get an A+. Use an if statement. So in an if statement, you have the if, which is a keyword, and then you put the expression in a bracket. The expression checks and is a Boolean expression. Now, so score is equal to 99. If score is 99, and notice that equal to is a double equal to sign. The equal to in line 4 is different from the equal to in line 2. The equal to in line 4 is checking for equality, while the one in line 2 is assigning 99 to score. So now, if score is 99, print A+, else it doesn't do that. So if I say score is 9, it doesn't print A+, because score is 99. Now you can use else to check for other scenarios. So if something is not true, do the order. That's what else is. If you're a boy, else you're a girl. So else is for if something or something. So yeah, you have two situations, either this or that. So if score is 9, print A+, else print not A+. But what if there are other situations I want to check for? Can I use only if and else? Now, there's what we call else if. So you can use if, then else if, else if, else if. Let me explain what I'm talking about. I can say if score is greater than 85, print A+. And I can go on to say else if. So now this is an else statement with an if expression. So it still checks for a condition. And it can keep on checking. It can keep on adding else if statements. So you have one if statement, you have else if. I can also go on to add another else if. So I can check for A+, B, C, D, and the dreaded F. So you can check all that. And after all that, you can add else. So you have if, else if, as much as you like. And you can also add an else. So if none of these expressions were met, you can do this. So you can say if score is greater than 85 and continue down to F, else number not valid. So if someone puts a value like -1, that is not a score. So you say, please put in a valid number. You can put that in the else expression. So in this else if, I say if score is greater than 70 and less than 85, put B+. Please, I'm using random numbers here. I don't know how they grade in your school, but this is else if statement. And like I said, you can end it with an else. Put a frowning face or a sad face. So if I put something like 5, which wasn't there, I put a sad face because all the conditions I checked for didn't cater for a value 5. So that is where you can use else. If nothing was met, put that. So next, what we're going to treat is for loops. So a for loop is like an iterator. So it starts, the first parameter you see in a for loop is where it starts from, where it starts counting from. The second is what controls it, the limit. And the third one is how should it increment? Should it increment by 1 value or 2 values? So in this for loop, we start with 1. So you initialize a variable I call it int I is equal to 1. Then next we say keep iterating until I is either less or equal to 10 and iterate by 1 value each. So I++. In that, ++ increments the value by 1. So this should print hello 10 times. So that's what happens here. We could also put in the value of I when it increments each time. So hello 1, hello 2, hello 3 till 10. That is the for loop. So it keeps running the code in between the brackets as long as it's iterating. So here, we're going to use a closure. I want to show you how to use closures in for loops because you can access and do different things with for loops. So this is a list. The name of the list is result. We can confirm it's a list by checking the runtime type. We print it and run the code. Yes, it's a list. So now that we know it's a list, while our for loop is iterating, we can put a closure inside. I've mentioned closures to you before, but I'm showing you what can be done right here. So we'll make a closure that prints something. So we use our lambda expression. Now, this closure I'm doing, this lambda expression, I can replace it with an anonymous function. It's still the same thing. So in this, I'm going to add, with each iteration, I'm adding this to result.add. So print hello. Or I can even add the value of the increment, that is I. So for the first value of result, it will be hello 1. So to get the first value, I just do this. I know this is a little bit, no, this is the second value. The first value as index 0. I have to print hello 1. So this is a little bit advanced, especially if you're just programming and you're not used to closures. But you can even add an argument to that and say hello I and hello X. So in our closure, when we're calling the function, we can add our parameter extra value. So it will be hello 1 extra value. Interesting, isn't it? So next, we're going to treat for each loop. In the situation where you want to just loop through a collection like a list, but you don't mind not knowing the current iteration counter. For example, in a for loop, at each loop, you could know at what point in the loop it is using the counter. So a for each loop just loops through it and performs operation on the elements. So let's say we have a list, clubs, having the elements of English clubs. Now I perform a for each loop on it and I perform an operation on each element as it's looping through it. So this is a lambda expression. And what I want to do is for each element in the club, I want to just print it out. Now that's parameter F. I can change it to anything. I can change it to club. It mustn't be F. So now I've looped through it and I'm printing each element. So when I print it, it prints Man U, Man City, and Arsenal. So that's what this does for each loop. In case I want to perform more operations on the elements, I can remove it from being a lambda expression to an anonymous function. Remember what we can do with the $sign to put a variable inside. So I printed each element is good. So Man U is good, Man City is good, Arsenal is good. So I'll change this now to an anonymous function. Have our curly brackets and voila. So with this now, I can add more lines to the code. So we also have for in. So for each variable in a list, so that variable club can be named anything. So for club in clubs, clubs is the list, perform an operation. So here I'm printing each element in the list clubs. So we have a while loop. But before we go on to while loop, remember that if you have a variable, an integer, and you put plus plus in front of it, what that is saying is that you should increment it by one value. So if I have a counter with an initial value 0, and we'll do counter plus plus, that increments the counter by 1. I need you to understand this because we would use it in our while loop. Now for while loops iterate and keep on performing an operation as long as a particular Boolean expression is true. So it's like saying while you are less than 16 or 18, don't drive. While you are, don't do this or do that. So here I have a counter and the counter is initialized to 0. And I'm saying as long as counter is less or equal to 10, print show people love. After printing show people love, we increment the counter by 1. So it keeps printing, and as it's printing, it's increasing the counter value. Once the counter value is greater than 10, it stops. Now, perhaps if I didn't increment the counter and I left it at 0, it will forever be less than 10. And this might turn out to be an infinite loop. That is, it's a code that will not stop running, because it will keep on being true that counter is less than 10. So here, a while loop checks for the expression before it runs the code. Now, assuming I made counter 11, let's say I made it a value greater than 10. So now, it sees 11 and comes to line 4, it checks while counter is less or equal to 10. Because counter is 11, it doesn't run the code because it's already greater than 10. But what if you wanted the code to at least run once before checking whether the expression is true? If you wish to do that, then you do what we call do while loop. So instead of while loop, you put a do. And then after the whole expression, you now put a while. So they call it do while. Do while. Do while. So here, we have a do while loop. So a do while loop, all things being equal, will run similar to a while loop. The only difference is that if perhaps the expression checked in the while loop wasn't true, it will at least run the code once. So whether the expression is true or false, the code will run once. So even if I made counter 11, it will run once and find out that, oh, counter is actually greater than the 10 with the limit we set, then it stops running. But for a while loop, it won't even run at all. So while looping, sometimes you desire to stop the program at a particular point. Just like when you're driving a car. The car is moving, but sometimes you actually want to stop and get something done. So let's say we have a list that we're searching through using a for loop. Now, we're searching for a particular item in the for loop. We want to stop when we find the item, because when we find the item, there's no use of continually searching again because we have found what we're looking for. You can stop a loop using a break statement. So here, we're going to print still searching. And what's going to happen is that we're going to search for a value. If we find 5, we break. If not, we print still searching. So what the program does is that it looks at the index. The index is looping from 0 to the index, the last index. So it checks 1. Is 1 5? No, it's still searching. Now it checks it checks the first element. Then it checks the second element 3 and the third element 4. The fourth element is 2. It's still searching. So when it reaches 5, it says, oh, I found 5, and it breaks. So it stops the whole program. Now, had it been that I didn't put break there, it will still find 5, but it will go on to still search. Now that is wastage of processing power. Right here, it may not be an issue because this is a simple program. But sometimes you actually want to stop a program at a particular time. It may not be that you're searching for something. It just wants, maybe you just want to stop it when a particular criteria is met. You can use break. If you don't use break, it will keep on running and running until probably the end of the loop is reached. Another keyword we can use is the continue keyword. So let's say we have a list of elements and we want to loop through it. And we want it in such a way that once we find a particular element, we don't operate on it. So what continue does is that it ignores every other code below it and goes to the next iteration. So perhaps I want, if I print this list now, it prints 1, 2, 3, 4, 5. But let's say I want it in such a way that once it sees the value 3, it should skip it and not print it out. So what I will say is, if it sees 3, continue. What continue does is that it will ignore that print command below. So instead it will print 1, 2, 4, and 5. So you can use this to skip. So the next is switch statement. This is similar to if statement you have seen earlier. So you have your variable input. Now we want that depending on the value of the input, we should print out something. So you check it using cases. So case 3 is saying if input is 3, print na. If input is 5, print ye. If it's 1, print na. Now the default you see there is if it doesn't satisfy any of these cases, then you print that face. You could use this in place of if statement depending on the situation. You can use it in place of if statement. And then the default is if perhaps the input is 0 and it doesn't satisfy any of the cases, then print that. So for this, it prints ye because input is 5. So the switch statement takes in the input, the variable, and then checks if it satisfies any of the cases. So that's that for now. There won't be any questions, and I see you in the next tutorial.